All right, so we're a couple minutes after 10. We'll go and get started. My name is Eric McKibben with Triphase Automation. Just wanted to take a quick minute and thank everybody for joining in to this webinar. We're going to have two gentlemen from SICK do some presentations on SICK's HDDM technology and what that means with their area scanners. I would ask you to please mute yourself during the presentation just so that we can allow the presenters to speak. If you have any questions, we'll take some breaks just to allow you to ask those questions, or if you want to ask those questions while it's fresh on your mind, please use the chat function and we'll make sure to get those addressed. So with that being said, I will go ahead and hand the ball off to Aaron. So I've stopped sharing. Aaron, you should be able to go ahead and take over. Aaron, I don't think we can hear you.
How about now?
There we go.
All right, and you can see my screen, right?
Correct.
So you can hear me, you can see my screen. Let's get down to business. Thank you very much for the introduction. And again, my name is Aaron Rothmeyer. I am a market products manager at SICK. And in particular, I'm responsible for the LiDAR product line, mostly the non-safety product. And we'll get into in a bit what the difference is between the non-safety product and the safety product is. But regardless, it all comes down to the same core technology. So I'll explain a bit about what that looks like and how it plays into some of our most latest products. So we're going to talk about real quickly what is LiDAR, brief history of it and how it works. And then we'll talk about the TIM 240 as part of the TIM family. And we'll talk about that in particular because it very greatly utilizes that HDDM technology, that high definition distance measurement. And without it, quite frankly, the TIM would not exist, as would many of the products that we're also going to hear about from Russ. So, and then we'll talk briefly about what we call a safety TIM, or the TIM 781S. And at that point, I'll hand it off to Russ. We'll talk more about some of our high-level safety products that we're very, very well known for. So a lot of people, when they think of LiDAR, they think of products like this. You know, if you Google LiDAR right now, this is probably what you're going to see. Some very large devices that are perhaps used on self-driving vehicles. That's where a lot of the press is looking right now when you start talking about LiDAR. But in reality, LiDAR goes back a very long ways. Right now it's being used on AGVs as well. A lot of AMRs or autonomous mobile robots that are running around. But it all comes back to a very early stage where our founder, Dr. Irwin Sick, back in 1946, saw an opportunity to use light, whether it's photoelectric or laser, to basically make workplaces safer. From the first development that he made, which was a photoelectric light curtain, it got turned very quickly into a safety laser scanner, which you can see here on the bottom left. The PLS was basically designed for one purpose and one purpose only, which was to make people's workplaces safer. From there, the LiDAR concept got turned into something similar but different. So this is a non-safety device. This is actually called the LMS 200, which performs a lot of the same functions. It just doesn't have that safety critical requirement, which means it gets used in a lot of really interesting applications. The issue with a lot of these devices, mostly for industrial applications, especially on an AMR or some type of autonomous mobile robot, is that they're big. They're heavy, they're big, they're typically rather expensive, and consume a lot of power. When I say a lot of power, I'm saying maybe 20 watts, 30 watts, something like that, which is a lot when you've got a battery operated device. So what we did is we basically took a lot of that technology that we put into those large, expensive devices, and we've really started to pare it down to just what's required in order to perform these types of functions. But we want to do it in a low cost and in a small way. And that's where we came to the TIM family. So the TIM family I'm going to talk about here in a few slides. But first, I wanted to show you real briefly just what these products actually do. So time of flight in general is this. We basically send out a pulse of light, we bounce it off of an object, and as we know the speed of light, we know how long it took for it to get out and back, we can multiply by that speed of light and we get the distance to the target. Time of flight is an extremely simple idea. It's used in ultrasonic sensors, it's used in our single point distance sensors, and like I show here, it's used in LiDAR as well. The difference with LiDAR is that internally we typically have some type of rotating mirror. And so when we rotate that mirror and we bounce the laser off of it, we get a spread, or we get a sweep of that laser line. And that's how we form the laser, the LiDAR concept, and that's how we basically set up fields, as Russ is going to show you in a bit, where we can actually detect the presence or absence of objects, and we can determine what to do based off of that. So we've taken it to a very high level. We've got a whole bunch of LiDAR devices within SICK that are outside of the scope of today's discussion, but just so that you can see, the devices basically at the bottom end of this range use HDDM, uses high definition distance measurement. As you go up, these products are all still very good, but at the same time, they're very large and they're very expensive, and they've got a longer range. So these devices that don't use HDDM are still very popular in our catalog. They're still used for a lot of applications, but in order to keep the size down and keep the cost down, we've transitioned mostly to HDDM for our new development, which allows us to keep us in the smaller form factor. So the smaller form factor that I'm referring to is called the TIM. And the TIM right now has grown substantially. It came out roughly about 2012 or so with some of these early devices like the TIM 510 here. And essentially, we've taken it and we've started to expand it from there to where we now have about 16 different models available of the TIM with varying capabilities. So you might see something, where we started out with like a 4-meter range. We've expanded the range up to 10 meters, even 25 meters at the upper end. And that allows us to do some applications such as SLAM, or simultaneous location and mapping, or just larger, covering larger areas. If we want to detect the presence or absence of somebody over a long range, we can do that with some of the more capable TIM devices. You'll also see the top one here is painted yellow, and that's a very specific thing within SICK. The yellow paint essentially means that it is safety rated, and we'll talk a bit about that at the end of this presentation. First, though, I wanted to talk about the bottom end, which to me, anyway, is the most exciting because all of this experience that we've got and all of this history that we have with LiDAR has really led us to be able to produce, in my mind, the TIM 100 and the TIM 240, which is where we've taken all that expertise and we've crammed it into this tiny housing that weighs about 90 grams. So it's very light. It's only about 3 inches tall, and it still has a lot of the capability that you would find in much larger and much more expensive devices. So we'll talk a bit about that. The TIM 240, just to be very clear, is basically our entry-level, low-cost LiDAR. It's designed to either do digital outputs or to do Ethernet output. So Ethernet output to us means we're basically going to feed out measurement data. Remember on the slide earlier where we're taking the measurements as we were rotating that mirror? Each one of those measurements can be fed out over the Ethernet connection. And that allows people to do some really interesting things. I mentioned SLAM earlier. You can also do contour measurement and that type of thing to actually determine the shape or the volume of an object. The issue with that type of output is that something actually has to interpret that data, which is easy to talk about, but difficult to actually implement. Reading all that data and actually doing something with it typically requires an external controller, some type of personal computer or edge computing device to basically read all that data and do something useful with it. And that's not, it's not something that can't be done. It's just you have to have a team or at least an engineer or two that are capable of reading that data and actually working it into something applicable to the particular situation that you're in. So we also have a version of this called the TIM 150 that has a built-in application. And that built-in application is very easy to use. It can be programmed in our SOPIS environment, as it says down here. And in SOPIS, all you really need to do is set up the zones that you care about. So you get into the software and you can set the exact areas that you want to detect something in. And then based off of that, you get a digital output that just says something is there or something is not. So we've got these two varieties based on what the customer's experience level is and what they're trying to perform with the sensor. We've got those two possibilities available. Where we typically see this employed right now is usually on an AMR, to be quite honest. If it's some type of mobile robot, we often put one of these on just to basically prevent collisions. We can also do things like making sure that the load is in the correct area. If you've got a load centered on top, you want to make sure nothing's overhanging. We can use a TIM to do that. However, we also see it used in other applications. Like, for example, we actually, I'll jump down here real quick. We use this in our own manufacturing facility. So you can see down here this bin picking or pass-through detection. When you reach into a bin, we can use the TIM to basically make sure that your hand has reached into that bin and then pass that out to some type of monitoring system. So if you're assembling a TIM and you need the housing and you need the hood and you need the circuit boards inside, as you reach into those bins, the TIM itself can actually be used to track whether or not you reached into those bins. So we're seeing that application frequently. We're also seeing this top one, similar to what I mentioned earlier, where basically the TIM is being used just to check to make sure nothing is hanging outside of where it's supposed to be, whether it's on a tote or whether it's on a AGV or whether it's in a bin. We can just basically make sure that nothing is outside of where it's supposed to be. It's a very, very handy device to have around. And a lot of that is all due to this HDDM technology. I've got a short video that hopefully will work well in Zoom. And basically this video shows the concept of HDDM. So HDDM, we call it high definition distance measurement. It's different than the typical LiDAR concept. The typical LiDAR concept, as you can see here, I'll pause it briefly, is basically, as I showed earlier, to take a single pulse and then deliver a single measurement. It's the way LiDAR has been done for years and years and years. What we've done with HDDM is we basically speed up that measurement. We take a whole bunch of what we call micropulses. So this can be up to 84 different micropulses per measurement. And then we don't deliver out a measurement for every single micropulse. What we actually do is we accumulate them. So as we take up to 84 pulses, we build them up and we determine basically what the most likely answer is or most likely measurement is based off of all those micro measurements that we've built up. And what that allows us to do is get a much more robust measurement because now any kind of flukes, whether it be a raindrop falling through the field of view or whether it's just some type of edge hit type event where the light is hitting different spots on the target, whatever it is, we basically negate the effect of that noise by adding the other 83 micropulses that we've accumulated. So it really helps to deliver a much more robust measurement. The other thing it does is reduces the size and it reduces the cost of the device, because now we don't need a very high power laser with a high voltage power supply and a whole bunch of infrastructure to manage that laser. Now we can use a laser that's similar to something you'd find in a DVD player, which is very low cost, obviously very small and lightweight. And so it's a much, much more efficient way to gather just as good of data. And that's really, like I said earlier, that's what's allowed us to take that huge product portfolio and bring it down to something that is very small, very manageable, and very easy to implement. So getting down here to the other end of the TIM portfolio, we have a product now that is different than all the other safety products in the catalog, and quite frankly, different than all the other safety products in the world, because nobody else is doing this level of safety. And I'll let Russ get into the specifics of what exactly performance level B safety is, but just for your information now, essentially we've got the TIM, which we've already talked about, and its capabilities. The TIM now has certification or compliance with performance level B, which basically means that it's allowed to be used in certain safety applications. Now, what those safety applications are, I'm going to hand that off to Russ to discuss, but essentially performance level B means that it is a level of safety that allows you to protect people in non-life threatening type applications. So if you just have a situation like here, we've got a lightweight mobile robot or something like that that could potentially bump into somebody, and you want to provide a higher level of safety than just a standard off-the-shelf non-safety device, we now have this performance level B type TIM available. So Russ, I know you've got this information, this flowchart in your presentation. Would you like to take the ball and discuss a bit about the safety type devices?
Sure. Thank you, Aaron. I would love to. Let me go to my screen. So just to introduce myself, I'm Russ Nikodem. I'm the safety application engineer here out of Wisconsin. I reside in Appleton, and my main territory is Wisconsin and Illinois, and my specific job is safety products. But Aaron and I cross over when his non-safe laser scanners are combined with my safety portfolio. So today we're going to talk a little bit about the safety part of the portfolio and what does the performance level B mean. And I'll even introduce a new product that I think will be kind of exciting that is not even launched yet. So we've got some good stuff to talk about here. So let me go to presentation mode, and you can all hear me, right? Thumbs up. Oh.
Yes, we can hear you, Russ.
Get to should be in presentation mode. Okay, so when we, first of all, this presentation we're talking about is HDDM, and Aaron did a great job talking about what is HDDM. High definition distance measurement. A lot of people at SICK here, we think everybody should just know what that means. And it is a patented technology that we've used in the non-safe laser scanners, but we've also brought safe HDDM into the safety world, which gives us that next generation scanner. To give you an idea, I've been with SICK for 20 years. We're on our 4th generation of scanner, and I've even been around for the PLS that Aaron showed earlier. So it's been an interesting ride. I can tell you this new technology really is a game changer in the safety world. When we redesigned the new laser scanner for safety, we focused on 4 real different things as it pertains to HDDM. First of all was ambient light. The old scanners used to fault out, sometimes a forklift would drive around a corner and the lights would shine into the scanner. They would fault out. Somebody would open a bay window or a garage door and the sunlight would come in and the scanner would fault out. It was a limitation in the technology because we were using only single pulses. We weren't averaging them, and it was a big problem. The other big issue you have, and if you look in any instruction manual for almost any laser scanner, is crosstalk. The ANSI standards, the ISO 13849 says that your laser scanners are supposed to be mounted at 300 millimeters. I can give you a dime for every time someone says, well, how do I do that? If I have 6 of them in a cell or 4, and I put them all at 300 millimeters, they crosstalk, and then we have issues. Been a problem for years. Been here 20 years, I've seen that. The other big issue was dirt and dust. I come from the paper mill area, coming here from Appleton, Wisconsin, and the paper mill people have busted my chops over the years about dirt and dust. And I literally have in one of my drawers a white glove for cleaning the lenses and stuff of the older scanners. Real pain in the butt. So this HDDM technology addresses these four things. So we worked on robustness first in this fourth generation. It's actually, this is the third, I'll show you the fourth, third generation scanner. So then one of the side notes I put in here was EMC. Now that doesn't have anything to do with HDDM technology, but I could tell you the new scanner is very much more robust in dealing with EMC applications than even our last generation. I was just in an application 2 weeks ago and tested side by side. I'll tell you, it was 1,000% better, just to give you an idea. What we're talking about here is laser scanners. If you haven't grasped that by now, I just wanted to make sure we're all clear. So I'm not going to hit on this too hard. This is HDDM in my world. We show the conventional single beam sending out lasers and measuring the time of flight measurement back, determine if something's in the area. When we do it in the new high definition distance measurement, Aaron said there's 84 measurements. That's 84 measurements or 84 pulses per measurement. So there's 80,000 measurements in a cycle as a laser scanner goes around. And with that, we have a ton of data, and that's how we filter out dirt, dust, ambient light. So we're going to talk about how this high definition distance measurement applies to the safety products, and why should you even care? You know, it's a patented technology. Why do you care? If the scanner works, it works. That's all you really care about, is that your scanner doesn't false trip. So keeping in mind, we're going back to these four things: ambient light, crosstalk, dirt, and dust. And so within our scanner, a little more than what you may need to know, we have a threshold. We're taking all that data back and we're averaging the measurements of the 84 pulses or 84 sets of laser pulses every measurement, and we average them. And you'll see here, this is an invalid signal. We know that it's another laser scanner or it's external light, so we ignore it. We get other signals that come in, and we can tell that by their amplitude that they're not a person, because they're inside of this threshold that we can filter out. Dirt and dust on the lens is going to come in really close to the zero line, so we can filter a lot of that out. So that's at the heart of it. The filtering that we're doing in the background is making the scanner way more robust. Another thing that we do is when we send the laser around, we randomly shift the scan angle or the scan frequency. And all of this phase shifting allows us to put all the scanners on a single plane and not have them crosstalk. So remember, we're talking about ambient light. We just talked about that. This is the reason we can deal with crosstalk. We don't have to, you can have all your scanners at your 300 millimeters and meet your ANSI standards and not have them crosstalk, because we're randomly phase shifting the frequency of the scanners. So at the end of the day, what does this give you? You get accurate measurements. Aaron talked a little about the LiDAR, and just to be clear, that the definition of LiDAR is light, LI, detection and ranging. For those of you that maybe, I had to look that up. So every time I've been doing this for 20 years, and I still have to look up what the hell does LiDAR mean. So it's light, detection, and ranging. When we get these 80,000 pulses and we use 84 of them per measurement, what does that give us? An average. That average gives us better accuracy in measurement. Why does that matter in a safety product? Because these products now are used for safety, as in detecting if a person walks into a robot cell or into an area where they're not supposed to. So they're digital, and they send you an output, hey, somebody walked into my area. But we also take that data and we feed it to the navigation system. And that's where the measurement comes in. The over Ethernet, the data goes for your autonomous vehicles, your AMRs, your AMCs, autonomous mobile robots, your AGCs, all the different devices that use. So now you use a safety laser scanner. In the olden days, it was just safety. Now I'm also using it for my mapping software. reduce the interference with other scanners. You could easily see why we do that or how we do that just by shifting the phase of the laser pulses. You get your lower sensitivity to external light and less sensitive to dust and contamination. So that's why you care about HDDM. So let's jump into, so on the left here, we've got a robot. This would be a collaborative robot. And then we have autonomous guided carts. Then we have autonomous guided vehicles. And then we would have, say, an industrial robot on the right. If you look on this is talking about performance level. And I'll jump into how to tell what your performance level is in your application. But if you look down here, the performance level B, which was the TIM, which Aaron talked about, is designed to work for automatic guided carts. And a cart would be like those carts that maybe go through the hospital and bring the food to the person who's got COVID and nobody can go in the room, or a slow-moving cart where the hazard is really low. You're not going to get hurt if this thing runs into you. It's slow-moving. It's very low risk. Then we're going to jump up into a little higher performance level, which is a C. And a lot of us in the safety world aren't used to talking about performance level C, but we're going to today because we do have a brand new product which fits into this performance level C, which fits in between an autonomous cart, slow moving, and an AGV, which is fast moving, and a collaborative robot and an industrial robot. It's right dead in the middle, and you need to know when you can use this product. And then our most traditional product, obviously, is our nanoscan and microscan, and those are our third generation laser scanners. To give you an idea, we invented the laser scanner. Everybody knows that, I'm pretty sure. So anybody who has a laser scanner after our patent ran out basically cloned or duplicated our technology. So we continue to advance as the leader, and we come up with this new technology because we need to stay ahead of the game. And being on our fourth generation helps us to do that. We keep improving, and our main focus is always going to be on robustness and making sure that your applications are safe and reducing the nuisance trips. So first of all, what is a performance level? Let's talk a little bit. Let's go through 3 examples. Performance level B. Let's talk about Aaron's performance level B type of scanner. So here's your B. This is your performance level chart as defined by ISO 13849, which is the international standard for safety. And you would start if your severity level is minor and your frequency could be either high or seldom, or quite often. Let's say it's seldom, and then your possibility of avoidance is very possible or hardly possible. So if you have low severity, and even if it's frequent and you can't get out of the way, you can use a performance level B device. Same scenario, you've got a severity is minor and your frequency is very long. So you're minor again, still stick with minor, but you have a higher frequency. So the cart is seeing more people, so it's quite often, but the person can get out of the way. You can still use a B. So this would be the chart that you would kind of use to say, hey, at least to give you a first glance, can I use that product? So the TIM can be used only in these severity level lows. And then it can be used whether it's frequent or the person can't get out of the way, but that means typically non-medical type of situations. Once we talk about S2, which is serious injury, which means it needs medical attention. And if the frequency is low, say, usually they would say like once an hour, once a shift, once a day, so the frequency is low and the probability of getting out of the way is reasonably good, you can use a performance level C product. So that would be that middle product that we're going to introduce next. So that product is designed for automatic guided carts again, that maybe move a little bit faster. Somebody could get hurt, but typically people can get out of the way. You get a beep, 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 hey, move out of my way. type of situation, you can use a performance level C. Most industrial applications historically have always said D, just because they're safe, or just because that's the pretty much the norm, and that means that you have a severity. You could get hurt pretty bad. It's quite often that you're in the area, and that you can get out of the way, but basically you can get out of the way. If you cannot get out of the way, if it's everything serious, and you very often, and you can't possibly get out of the way, then you have to go to performance level E. That's like an airplane. You're up in the air. Hey, you're not good. You're going down. D is your most common industrial performance level. So if you have more on this, or you don't know what your performance level is, we have a full service group that does this. And it all starts with the risk assessment, and we can help you do a risk assessment, and we can determine those task hazard pairs. Now we can also do the safety concept. We can do installation, we can do validation. So if you need help, we're there. We do have a full service arm that's able to help do this. So I'm going to jump into this new product. I don't always like to show new products until they're really here, but this product is, I would say, 6 weeks away. And it is the world's first LiDAR, light detection and ranging device, a multi-beam that is safe solid state. So at the end of the day, it's the same technology as we're talking about, time of flight. But what makes it the first in the world is it's the first solid state safety device, which means, if you don't know what solid state means, I had to look it up too, just to be sure, it means no moving parts. So on a typical laser scanner, whether non-safe or safe, you've got the spinning wheel, you've got moving parts. So this is an innovative new product. How does it work? It's going to be very similar to the typical laser scanners, where you have a warning zone and a protective zone. It's going to have 150 degrees. Our typical safety laser scanners have 275 degrees, so they can see behind themselves. This product is designed really for the AGC market. What does that do for you? It means it's going to be low cost, because the carts, that market is just really low cost. And it's going to be very small, because the carts are very small, and it's going to be very user friendly, because that's not a market that is super techie advanced. So you've got a lot of benefits with this product. And this product is designed for carts, but there's no reason that it can't be used for just simple detection, even though it is a safety device. And it could be replacing a bumper, or on a gantry that's moving, and you want to just know if there's somebody in front of it. That type of application would be really good for this, because there's no sender receiver. You don't have to have a light curtain, and you don't need the expense of a full laser scanner. So it's based on a solid state technology. This kind of gives the inner workings of the laser scanner. It's going to have 8 laser arrays. So that's where it uses the HDDM technology. This laser is not just one laser beam. It's, in this case, it looks like 4 laser beams being shot out. And then it's taking back the data, averaging it, doing some math, and giving you an output based on what all of these are seeing in an area. So it's going to be a pretty slick new device. Going to have M12 8-pin connection on the rear, and it could replace, like I say, bumpers and things like that, which everybody hates. So then we jump into our what is our bread and butter, our newest product, which is our NanoScan. I've got one here. The beauty of the NanoScan, we have the 3rd generation scanner is the MicroScan. So there's MicroScan and NanoScan. They're both on the same platform using HDDM technology. One is just a bigger brother than the other. This is the hottest new product on the market from SICK for a couple of reasons. They made it really small. It's the smallest, the most compact laser scanner on the market. I'm not sure that it's smaller than the TIM, but when we say this performance level D safety, this is the smallest scanner on the market. So that makes it really unique. It uses all of the robust HDDM technology jammed into a smaller package. What makes it really nice for customers is because this is designed for the AGV, AGC market. Again, remember I told you AGCs, automatic guided carts, are very cost sensitive. They're, the whole cart might cost $10,000. You can't have a laser scanner that costs $5,000. So this product has all of the safety that you want at a very low price. I think the list price was even under $2,500. It's a crazy good price point, mainly because it was designed and marketed for the AGC market. So you get all the robustness, you get all of the technology at a low price. One of the unique things that we tend to forget sometimes at SICK is that we have 275 degrees of detection. Almost all of our competition uses 190 or 150 like our scan grid. What this 275 degrees gets you is you can set one scanner on the corner of a machine and you can scan safely two sides of a machine. If you had 270 degrees like our older scanners, you can't do that, especially since we have the longest range on the market. Sorry about that. We can go out to 9 meters on a protective field. When you go out 9 meters and you try to scan two sides of a machine, you've got a little gap. So we just increased it to 275. Once again, it seems like a small thing, but if you want to fully protect a machine and just put one scanner on the side and get two corners, you need that. So this can replace two scanners at a low price. When we set up a scanner, and that's why I put in here, it's 275. That is a unique selling point to SICK. Nobody else, better be careful. I don't know, most of our competition don't have that. If you talk about a nano scan, which is our low cost AGC type of scanner, that's a 3-meter protective field, but we also have a 9-meter range scanner. So not only do we have the longest safety range in the market, we have the largest scanning angle on the market. So there's a lot of benefits that come along with this new laser scanner. This gives you an idea. So the nano scan is we call it the small brother and the big brother. The big brother, if you need 9 meters of range, and people do need that, you jump to the micro scan. If you want small and you need it to be very low cost and 3 meters is a long enough range, you go with the nano scan. Both use the same technology. It's just a matter of what your needs are. All the scanners have diagnostics built into them, very easy to program. They have the nano scan in particular has safe IO. It also has Ethernet data. It can be used in a lot of robot applications very well. So it's perfectly suited for like robots and for autonomous vehicles. The idea is everybody knows, or most people know, that SICK always has cloning modules built in. The cloning module is the plug that plugs into the scanner. So on this one, you can get Ethernet. That's not safe Ethernet. That's Ethernet mainly for programming, Ethernet for data, and so on. All of your you could still use the conventional I/O inputs and outputs. This is what your scanner would look like. You've got your scanners and they tie into a safety controls. Some of the things that we do differently is you can get up to 128 different fields. What does that give you? You can partition out your area if you've got a welding cell and there's a lot of dirt in one area to the left, but not the door is to the right. I can put 2 different fields out there and have my my safety field that's over by the welder that is dirty. I can have that be, say, I have to see the dirt 6 times for it to say that it trips out. But by the door, I want that super fast and it's not dirty. I can break those fields out and I can say, by the door, I want the scanner super fast. But by the robot where it's doing welding, I can let it be a little bit slower by increasing the number of scans it has to see in order to detect a person. So that's what they're trying to show in here. We got 8 simultaneous fields, and you can break them up, and you can individually customize each of the fields for your needs. We do other things like contour detections. That's for, say you're trying to drive an AGV into a docking station, and you need to know that the posts are there. So when you put it in, it says, hey, I'm going to look for those fields. And if I'm there, that means I'm parked in the right spot. The other way that is used, you could have that looking at the same example. I got a robot cell. I got 2 fields, one to the left, one to the right, and the one to the right is looking at the door. So somebody opens that door before they even enter the cell, the contour is gone, boom, your laser turns off, and now you've used the scanner in another way to detect that the door was open, and you can give yourself some extra time because you've detected that before the person entered the cell, you've detected that the door opened because the contour is gone. So some of the techy stuff on it, the NanoScan 3 meters, 275 degrees, performance level D. Comes in 2 different forms. If you do need dual OSSDs, so if you're doing 2 sides of a machine, because we do have the 275 degrees, you've got a machine to the left, a machine to the right, or you've got a machine on the right-hand side of a 90 degree, you could have OSSDs, right, OSSDs out. OSSDs are your safe outputs. So you can scan multiple, use one scanner truly for 2 different applications and have 2 separate safe outputs. So some of this gets into the weeds a little bit. You can buy them with or without Ethernet. You can get them Core or Pro. Core does not have dual outputs. It's your most basic scanner. A lot of people love it because it's super easy. If you jump into the Pro, usually it's still super easy, but it gives you more capabilities. 128 field sets, dual SSDs, more pins, so more inputs and outputs to work with. So it's just a more capable scanner from an input and output standpoint. So at the end of the day, what are we talking about? The longest range scanner on the market. This is why people come to us. We've got the 275 degree viewing area. Nobody else seems to be able to do that. We also have a scanner that's rated for outdoor. What I put that in there because we're using the same technology. That HDDM technology allows us to get a safety rating even as the scanners go outdoor. Nobody else can do that on the market. One of the new things that we just came out with is EtherCAT, safety over EtherCAT. We have safety over Ethernet SIP safety. We have safety over Profibus. So we have all of the networks, safety networks, well, not all of the common ones covered, or you can get the scanners with just straight IO. One thing we also do is we create DIY, do-it-yourself kits for most of your robot platforms. So you buy a robot and you want to safeguard it. We have a kit, including the program in the safety controller, so that you just have to modify it slightly. It's PLD rated, it's written by a safety engineer, and it's very good. So if you want a DIY kit for just about any robot, we can do it. We have the smallest scanner on the market. We have the longest range on the market. We do have, sometimes people will be wanting visualization. We do have a visualization tool that ties directly into your HMI, and it shows what your scanner sees. It shows the field that it's in. It shows the events. It shows if the lens is getting dirty and things like that. It's a really cool tool. And you don't have to have a camera videotaping people. You can see what's happening on the screen, and it keeps the events on the screen. And so you can look at, hey, when do the events? Hey, at 9 o'clock every morning, Joe walks across the field and the robot stops. Next thing we have is the first ever solid state safety scanner. We have the largest portfolio on the market, and we have that patented HDDM. I put this slide on here. I know it's a lot of words, but these are the reasons why SICK is #1 in the market. And that's why, why people come to us for their applications, whether they're difficult or easy. So there we are, right on time. I was scrambling there for a little bit, talking kind of fast, but wanted to give you a pretty good overview of you know, what the new portfolio looks like. So we could open it up for questions. I can either stop sharing my screen or leave this up there. Any?
Thank you, Russ. So far, doesn't look like we've had any questions come in through the chat. But I guess if anybody does have some questions, please feel free to unmute yourself, ask away, or send them in through the chat function. Russ, if you would go ahead and just unshare your screen.
I can do that.
All right, well, it doesn't look like we've got any questions coming in. I don't know if anybody has anything to add or any questions that they want to ask, but just putting up my contact information here on the screen. So if you think of some questions afterwards, tomorrow, whenever it may be, feel free to reach out to me or your local sales engineer for Triphase or iMac motion control. They can answer any questions you may have. Other than that, I guess I want to thank you very much, Russ and Aaron, for your time today. Very interesting information.
Thank you. I appreciate all your
Thank you, Eric.
Other than that, I guess we'll go ahead and close out the webinar. I appreciate everybody taking the time to participate.
Thank you.
Yep. Have a good day. Thank you.
Thank you.